So, guys, welcome again, as always. Bright and attentive. Rapid manufacturing. So we're going to talk about a few different concepts today, and this is something that is not fully electronics related, but it's kind of where you go with your projects. So these are some Nike shoes. These are got some 3D printed stuff, and what 3D printing is, we'll get into. However, the beauty of this picture is that Nike went from making shoes the old-fashioned way with rubber and complicated process, all stuff, and they actually 3D printed the sole, or the base here, and I think it's actually out of nylon. But they were able to 3D print this and try a completely new design, and that thing probably printed in a couple of hours versus the old-fashioned ways. And they're able to test and change and do with something they couldn't do before. And that thing is amazingly lightweight. The structure here is all 3D printed, and it's kind of a neat thing. But how can we use it? What is it? How does it apply to you guys? Okay, so 3D printing. What is it? So back in the day, everything was done as called subtractive machining, subtractive methods of making things. You take a solid chunk of something, like a piece of wood, a piece of metal, and you cut away until you got the shape you wanted. Additive manufacturing, which is kind of this new trend of where things are moving to, is where you add material and you make something new out of it. So, for instance, this little Yoda here, it actually is made out of plastic, and I'll hand out some samples at the end. But what they do is they actually put down, imagine a hot glue gun. So you have a hot glue gun on a table. You take the hot glue gun and you lay a little bead of hot glue, and you lay into some circle, a shape, any circle, right? This one's done in kind of a circle shape. So you do this, and it's robotically controlled, and it just does one layer of hot glue, or hot plastic. It then moves up a layer, and it does the same exact thing right on top of the other. Up a layer, does the same exact thing. Up a layer, and it keeps doing that over and over and over and over again until you get your shape. This is how a lot of the lower end 3D printers work. They'll just do a layer of plastic and a layer and a layer and a layer. You can build out whatever shape. We have people building, entire scenes for architecture. You have really complicated stuff using other methods. So 3D printing is not just plastic. You can 3D print metal. You can 3D print ceramics. There's a whole host of plastics, and you don't just have to do, stacked shapes. This thing here, it's not all stacked shapes. What they did is they actually print a second material. So say I want to do an overhang. Say I want to print my arm that goes like this. Well, if I'm doing layer by layer with a hot glue gun, right, I'm going to get up to here. When I get to this layer over here, things are going to start to fall. Like there's nothing underneath here. That hot glue is going to kind of sag and fall. So what they do is they call a support material. So they'll print a second material, a little structure, scaffolding essentially underneath it. So they print on top of the scaffolding. Then you can dissolve out, you can melt away, you can get rid of the support material and make really complex, intricate shapes. How would you make that otherwise? We talked about hollow sphere last time. This is not easy to make if you're taking, say, a solid chunk of material and trying to make that guy. 3D printing metal, pretty cool. I think it was one of the major aircraft companies that makes big planes. They recently said that they've gotten pretty high strength and they're doing the majority of one of their engines out of 3D printed metal now. Not majority, but they're doing a lot of parts out of 3D printed metal in engines. These things have high temperature, high speeds, a lot of friction, and so the 3D printed metal is actually coming along quite nicely in the manufacturing world. 3D printers, what do they look like? So I showed you what the parts come out as. This one's actually really big. This doorway here is about as tall as me, and that's a very high-end one. But that thing can print pretty big stuff. This is the replicator tube by MakerBot. They kind of popularized the lower-end home use 3D printers. I believe this school actually has this. And this is what some of the pieces I've made are done on. And this is about yay big. This is a new 3D printer. They do that kind where this is actually, we use a stereolithography. It gets a little advanced in the talking what it is, but it's essentially doing the same stuff. You're doing layers and layers of plastic or material. It has a support mirror under the Eiffel Tower sometimes. Stuff dissolves away, and you have your part. This is actually a very low-end 3D printer, but as you can see, you can actually make still pretty good shapes out of it. And this is the kind, there's $300 printers out there, $2,000, $3,000, $100 grand. There's a whole range. And then there's bigger 3D printers that can do the metal, can do all sorts of stuff that does really kind of complex, cool methods. And again, if you want to learn more about it, please ask. If not, Google it. Google FTM, SLA, SLS. There's a whole bunch of different 3D printing technologies out there, and they're pretty cool. And every day they're changing and growing. But there's other rapid manufacturing techniques out there. You don't just have to do 3D printed. things. Say you want to make something out of wood, or say you need a flat shape. You don't need 3D printed, and you want to take the characteristics of wood. So laser cutting. Some of you guys here have gotten laser cut pieces already. So laser cutting essentially is just a laser that cuts things, and it cuts 2D. You take a flat sheet and you cut it. You can do this on metal. They have plasma cutters, and you can do it on thin wood. So traditionally, the laser cutters nowadays are kind of smaller for more hobby type stuff, but you can do quite a bit. Complex, intricate stuff. The laser cutters can hold a pretty high tolerance. You know, it's as fine and precise pretty much as the width of the beam and the motors. So you're talking within a few, less than a piece of paper thick of accuracy. So pretty accurate. You can cut out gears out of acrylic, out of plastics. You can cut out of wood. You can do some pretty intricate designs. You can do stuff like a square cut, which is usually hard to do with other methods. And then little fun projects like the desktop catapults. And that's all laser cut. What do they look like? So this is a couple here. This one's about 20, 30,000, 15,000, something like that. You'll see it at Maker Faire. This is a common one. The bed's about yay big, and it can be probably about 18 inches by 2 feet, or 12 by 2 feet, something like that. And cut out quite a bit. This is kind of looking in action. And there's bigger ones. These can cut out metal. They can cut out like inch-thick sheets of metal. It depends on how strong the laser is, whether or not you use a gas assist or not, and then what kind of metal, what kind of material. Like this little wood laser cutter cannot cut metal. It just does not, the bulb or the laser behind it does not have enough wattage to actually cut metal. But there's a lot of technology there. And the nice thing is, this laser here, I can cut out a circle, I can cut out a complex shape like that in 30 seconds, a minute. And it doesn't cost that much. So it's again more like 3D printing. I need to get something complex made that I couldn't make easily any other way, or it just costs a lot to get made out of metal, or cutting traditional ways. A second. And now it kind of allows me to do these things which I couldn't do before. And if you have an idea, you send this to a place, and for 20 bucks later, you get all your parts cut out and done. And you're kind of like, wow, I couldn't do that before. And you get it done tomorrow. It's kind of the beauty of the rapid manufacturing. Shoot.
How does light?
Has light cut metal?
Yeah.
Usually with the gas assist as well, and it actually kind of burns and erodes out the metal. Very high heat as well. So it kind of just burns and evaporates out. There's a bunch of different metal cutting techniques using lasers, using chemical, using sparks. So you can do, there's a whole bunch of kinds. We can talk after for the different types of metal cutting that can be done with electricity. And they're, lasers, chemical, electrical, discharge, evaporation. There's a whole bunch. But that will go, again, beyond kind of this talk of the rapid. But I just want to show you. And the last one on, here is waterjet. So you can actually get thick pieces of metal cut out with water. And actually the water is run through with a little bit of grit, so it's kind of like shooting like high powered, like a really high pressure hose at a very fine nozzle with a little bit of sand in it. And actually you can cut through metal. You can cut through like 4 or 5 inches thick of steel very quickly. So that's also a pretty cool one. And again, it's rapid-ish. The other main way of making things, CNC machining. If you want to get something made out of metal, the subtractive way, there's a lot of companies out there that will now take your design, your model that you've done in SketchUp or CAD, and machine it out for you. So CNC machining works by cutting away metal, machining it out using kind of round cutting bits. Kind of like you guys have used a drill, that drills straight down. These bits are designed to cut sideways, so you can actually cut metal and cut it away like that. Different kinds, there's turning, there's milling, so this one kind of goes and cuts like this, cuts out shapes. This one, you spin the part and you cut away by cutting into the part and while it spins. Usually use coolant. It's more of a heavy-duty operation, but you can make intricate small parts and you can do quite a bit. It's kind of cool. I like metal machining. You guys don't have to. It's still within the rapid manufacturing, but usually it takes a little longer. You have to clamp your part down, set it up, measure stuff, get it precise, write all the code behind it, and then watch it go. And it can take 4, 5, 6 hours to go. It can take as long as the 3D printing, although you still got to do all this. If you want to get complex shapes, you now got to re-clamp it this way, clamp it this way, clamp it this way, do this, put it on a 5-axis machine. You start to get more complicated. It starts to get expensive. So that's why 3D printing is nice. You can do this complicated stuff with almost little cost. What do these machines look like? So these machines, there's a CNC wood router, and this thing actually can do, it looks like 5-axis maybe. It can do really big things. Some of these things can do cars. They can machine out a car out of wood or foam. And they're very big, so you can cut out big complex shapes. not really small precise stuff. You want to get small precise, you get a CNC mill. This thing, the bed travels this way, and the head travels this way. So you get 3 axes. And you can cut all sorts of stuff. Mostly metal, hard plastics. This is, again, the CNC turning. This is a pretty big bowl. This thing's probably about that big. And that will just spin. This bowl just spins faster and faster and faster. And you cut away little by little, like that, shaving away a little cutter. Yes?
I have a question. You mentioned 5 axes a few times.
Yes.
Can you please explain that a little
Sure.
bit more?
So you guys have 3 axes, right? You got your z-axis this way, x, y, in whichever orientation you want. So as my machine cuts or moves, I have my cutting bit here, and it can move this way, it can move this way, and it can move this way. Most 3D printers are 3 axis in that they'll lay the plastic down in these, and it'll move in these 3 directions to do it. 5 axis, well, 4 axis, usually in machining speak, you go your z-axis, your x-axis, your y-axis for your cutter, and then you add a 4th axis. So as the thing machines, this bit rotates and cuts away the metal as it goes. As I add the 4th axis, I now add something that can spin here. So I can actually cut this way and spin at the same exact time. And that's 4 axis. 5 axis, now I have those capabilities, but I also can now do this with the head. I can actually rotate. And you have different 5 axis types, but you're adding a different degree of flexibility in the machining capability. So if I want to do X, Y, Z, and now I want to make a kind of a weird, goofy angle cut, and I want to sweep it around. With a 5 axis and turning, I can do this. And I can cut some pretty cool, complicated parts. I don't know if I had one. So this is 5, potentially 5 axis. Actually, I think it's a measuring tool, but this would be what 5 axis could do. Is you turn it, you machine and cut, but you also cut at an angle, so you actually do a different kind of shape. So does that explain 5 axis?
Yes, thank you. I was having a little bit of trouble visualizing.
So it's usually just when the head kind of rotates a little extra, and it's just allow you to machine a little bit more in a little goofier pattern. But each new axis you add in machining costs quite a bit more. That's why things are turning towards the 3D printing, because it's the 3 axis, so you can do as much as that 5 axis or more in terms of shape. So something that a friend of mine turned me on to, which is kind of really cool. This is free software that does this. 123D Make, and it's I think owned by Autodesk. You design your 3D model, you then load it into the software, you hit slice, and it slices up the shape into a bunch of these interlock. You ever guys do those puzzles or those little kits for dinosaurs where you interlock all the little wooden pieces and you can like stack them up and make a little dinosaur? You can take whatever 3D design you want and hit slice, and it calculates and designs all the little slices, all the pieces. It lays this all out. You can cut it out of cardboard or scissors if you want, or you can set it to get laser cut. So if I say I wanted to make this little T-Rex, I could make a T-Rex model, download one for free, hit slice. 5 minutes later, I have this thing ready. I send it to laser cutter. They cut out all my cardboard, all my wooden pieces, and I just stack them all together or interlock them all to make a cat, to make a whatever. I don't know what that is. So that's cool. Or make like an octopus type thing. And literally, you make a 3D model of the octopus. You don't have to calculate any of this stuff. It does it all automatically. So rapid manufacturing, rapid prototyping, this allows you to make a shape, make it out of cardboard. I mean, this, how much cardboard is this? A box and a half? Get a laser cut. A day later, you can make your shape and see how this really well, how it fits. Fill it with some foam or some like plaster or whatever, and you start to get some shapes. So then you can then start to go, and it teaches you something about, the whole point of prototyping is to teach you something so you can then make something better, make it correct if you want. So that's kind of cool. So you're welcome to check it out. So, what do you guys do? If you want to make something and you want to do one of these methods, I'm going to give you a glossy overview of them. What can you do? There's different services out there. These are just some. I'm not saying that any of them are better or worse than others. I've not used too many of them, only a couple. But there's a couple. So Protomold, what they do is they'll take your model, you send it to them, and you say, I want this injection molded, which is another process we might cover another day. But it's essentially making a plastic part. They'll take your design, they'll make it. 2 days later, if you want, you can have your parts and you can have 500 made. Costs a little bit, but it's still within the range of if you're launching a product or launching an idea, you can do it. First cut, they do the machining it. So there's all the CNC Machines that do 3 axis, 5 axis. You send them a model, send them what you want. They'll machine it out for you and then send you one back tomorrow. You know, pretty penny, but normally you'd have to go to a shop that does this. You have to find a shop, you have to send them your design, you have to talk back and forth, they have to do their stuff, you pay them, and then they'll finally make your part 6 weeks later. These guys do it tomorrow. So it's kind of, if you're doing rapid stuff, you want to get your idea out there, those are the places to go. Shapeways, check this site out, they're kind of cool. They have a whole bunch of 3D models already done. You send them a 3D model, they'll 3D print it out of any material that they have, and that's like 100 materials. They can do the ceramics, they can do the plastics, they can 3D print metal. There's a whole bunch of others, and they're going to do plasters. No one's really successfully 3D printed wood yet, but people are getting kind of close to a wood type substitute. Pinocchio, similar, they do, exactly, I think you send your stuff in, but they'll make it for you next day, very quick. The 123D Make, that's that site, the software that does the slicing, takes your models. And there's also one with 123D Catch, which is cool, where you take 40 photos of the same thing with your iPhone or iPad around, and it'll actually digitize and turn into a 3D model for you. So if you say wanted to make yourself and get it 3D printed, you can take an iPad, take 40 photos in a circle around you, have someone do it for you, and then it'll generate the 3D model, full color, and then you can send it to Shapeways, and then a day later have a 3D printed full color face of or bust of yourself if you wanted.
What's that called?
123D Catch. It's all in the Autodesk 123D stuff. So yeah, this is rapid. I mean, we're talking that, yeah, I could do this another way, but I can do this all in one day and have it by here by tomorrow if I wanted. That's the cool part about some of the newer technologies. There's a couple more here. We'll skip, we're kind of running out of time. Questions? Let me shut up the camera, I'll show you guys these parts.